Hello and welcome to the channel. Myself Dr. Papdivor, Assistant Professor in the Department of Chemistry, Brainwire University. Today we are going to discuss about fluorescence spectroscopy. In the previous video, we discussed about the electronic spectroscopy, and the electronic spectroscopy meant that the excitation of the electronic levels by absorption of light. So by absorption of light. So here that one was absorption spectroscopy. But here we are going to discuss about emission spectroscopy. So what is emission spectroscopy? When the molecule absorbs light, it goes to excited state. If we measure that light, the amount of light absorbed, then we called it absorption spectroscopy. However, if we remove the light, or if we whenever that those electrons that went into the excited state, when they return to the ground state, what happens? They will release the energy, right? So they are coming from a higher energy state to lower energy state, so they will release the energy. They can release the energy in two different forms. They can either release the energy in non-radiative way. Non-radiative way means by transferring the energy to other molecules, like that. So they can do it like that, or they can release energy in terms of light. That is the radiative way. If they emit energy in the radiative way, that is the emit energy of light, energy in terms of light, then we call it photoluminescence. And that is what our fluorescence spectroscopy is all about. That is photoluminescence, and that is our photoluminescence, which is a emission spectroscopy. Okay, so if we go into the Jablonski diagram, this is all that matters. That is fluorescence spectroscopy or any emission spectroscopy, electronic emission spectroscopy, is based on this one, this diagram, Jablonski diagram. So what is Jablonski diagram? You see, we have electronic levels here. So S signifies singlet. Singlet means we have two electrons. Singlet means we have two electrons. One is up spin, one is down spin. So they are combined with each other to form a singlet state. And then we have triplet state. Triplet means the two electrons are not paired, they are in the same spin. So they are forming a triplet state. Okay. So this is S naught or S0. S0 means ground singlet state of the electronic levels. But this is what? This is S1. This is S1 means this is first, one signifies first singlet excited state. So the ground state is possible only one, which is this one, and this one is first excited state of the singlet state. Okay, then we have the second one, that is the second excited singlet state, like that. Triplet state is in the ground state is not possible, so triplet T1 comes here. So that is what first excited triplet state. Okay, now when we gave energy in absorption spectroscopy, what happens? The electron took the energy and went into the excited state. Now you might think, what are the other lines that are present in here? So you see the energy gap of S0 and S1 is quite high, right? Right. So this is a quite high energy gap, but these gaps are quite small. These are basically vibrational levels inside electronic energy levels. These are vibrational levels, these small ones. Okay. So every single electronic state is associated with vibrational levels. This S0 or S0 is associated with vibrational levels. S1 is associated with vibrational levels. S2, T1, all are associated with vibrational levels. So when an electron absorbs energy, it can go to the ground level, ground vibrational level. This is first excited vibrational level of S1. It goes like that. So when an electron absorbs energy, it can go to the ground vibrational level of S1, or first excited vibrational level of S1, second excited vibrational level of S1, it go to anywhere. Okay, so anywhere in S1. any vibrational level of S1. It went. Okay. Now it will come back to the ground state. As I told you that the excited electrons will come back to the ground state. Fine. Then as I said, it may come back in a radiative manner or in a non-radiative manner. The radiative manners are these two, the green one and the red one. And the non-radiative ones are bent lines. That is the yellow, violet and blue. Okay, or sky blue. So you see, we'll go one by one. So you see, the first we will discuss about non-radiative relaxations. So the first one is vibrational relaxation. What is this? Non-radiative means they are not emitting any form of light. Fine. So the non-radiative manner, from the higher vibrational level, it is coming to the ground vibrational level of a singlet state in the excited state. In the excited state, in the excited electronic state, this is an excited electronic state. These are the different vibrational levels. So the electron is at a higher vibrational level of S1. So it is coming back from that in a non-radiative manner. So that is not emitting light. That is called vibrational relaxation. This has a very short lifetime, as well as how does this happen? This may happen because of the electrons losing energy towards the solvent molecules. Okay. Then the next one is internal conversion. What is internal conversion? Internal conversion is happening in the excited singlet states. Remember, excited singlet state. So S1 is an excited singlet state, S2 is an excited singlet state. So if the electron is coming from S2 to S1 but in a non-radiative manner, then it is called internal conversion. Okay, so it is coming from singlet to singlet but from a higher excited state to a lower excited state. Okay, this is called internal conversion. Next one is inter-system crossing. Now, another possibilities of a non-radiative relaxation is when the electron goes from excited singlet state to excited triplet state. So it is going from one system of singlet to another system of triplet. So it is going from S1 to T1. It will be termed as inter-system crossing. So it is crossing the system from singlet to triplet, and that is why inter-system crossing. Then we go to the radiative relaxations. What are the radiative relaxations? There are two types of radiative relaxations. One is fluorescence and the other one is phosphorescence. The fluorescence is when the electron comes back to its ground electronic state, that is S0, from the first excited state, that is S1. Okay, first excited singlet state. So S1, that is first excited singlet state, from here if it is going to ground electronic state, it radiates, and it radiates light or emits light, then it is considered as fluorescence. Now you can imagine when they absorb light, the electron naturally goes to a higher vibrational level, but the electron always comes back, for fluorescence always comes back from the ground vibrational level of S1 to S0, and that is why the energy that was absorbed will always be higher compared to the energy that is emitted, and the amount of shift in the lambda, that is from absorption to emission, is called the Stokes shift. As I said, the absorbed energy is always higher compared to the emitted energy in fluorescence, right? So there is a change in wavelength because higher energy has lower wavelength, lower energy has higher wavelength. So from lower wavelength to higher wavelength, there is a shift, and this shift is called Stokes shift. And as you can see, fluorescence molecules are generally known as fluorophore, and there are various different types of examples that we have in nature, mostly organic compounds with large conjugation, or large aromatic rings are shows fluorescence spectroscopy. And if we see practical examples, you see this is under visible light, but if we give UV light, it absorbs UV light and emits visible light. Similarly, another set of fluorescent compounds, you see, in terms of UV light, they are emitting light. Again, these two are the same picture basically. In terms, in presence of visible light, you see there is no emission, but in presence of UV light there is emission. So this is radiative relaxation. That is what we call fluorescence. Okay, and fluorescence is instant. The moment we remove this UV light, this emission will be gone, because it is instant. The when we are giving the light, then only it will be present. Okay, which is different from phosphorescence. Phosphorescence is basically a similar thing, only the excited state from the electron is coming is first excited triplet state, not the singlet state. The fluorescence was S1 to S0, the phosphorescence is T1 to S0. Okay, and unlike fluorescence, in phosphorescence, some electron may get trapped in the metastable state, and that is why the phosphorescence happen over a longer period of time. As I said, if we remove the light, fluorescence will be completely stopped. But if we remove the light in case of phosphorescence, we will still get the light after some time. As you can see, after 1 second, after 640 seconds, we are still getting light of phosphorescence. That is the basic difference. In terms of electronic levels, T1 to S0 is phosphorescence, S1 to S0 is fluorescence, and in terms of timing, this is the difference between fluorescence and phosphorescence. And thank you. That is the all.